The addition rule, illustrated by this Venn diagram, shows us that the probability that events A or B would occur is equal to the probability that event A would occur plus the probability that event B would occur minus the probability that both would occur, the probability that events A and B would occur, because the intersection gets added in twice. But let's suppose that we have a situation where the events are mutually exclusive. And what that means is that these events cannot occur at the same time. That would be illustrated by this Venn diagram here, where A and B do not intersect, because events A and B cannot occur at the same time. For instance, it can't be daytime and nighttime at the same time. Now, in that case, whenever we have mutually exclusive events, the probability that events A and B would occur at the same time becomes 0. So, the addition rule, the probability that event A or B would occur, becomes then just the probability that event A would occur plus the probability that event B would occur. So when we're finding a probability of a union of events, then that's the question we have to ask. Are the events mutually exclusive? If they are mutually exclusive, then we don't subtract anything. If they are not mutually exclusive, or in other words, if they can occur at the same time, then we have to subtract the intersection off. Let's look at an example. Let's suppose that we're going to throw 2 dice. And I want to know the probability that I would throw a sum of 7 or 9. Well, I know from the union, which is also the OR symbol, I know from that formula that I'm going to add. But then I have to ask myself, are these events mutually exclusive? Can I throw a 7 and a 9 at the same time? A sum of 7 and a sum of 9 when I throw 2 dice? And the answer is no, I can't. So these events are mutually exclusive. So all I'm going to do is find the probability that I would throw a 7 and add to that the probability that I would throw a 9. And we know from earlier videos that this sample space contains 36 outcomes. And these outcomes are all equally likely. So what we need to do is determine then, well, how many are there that would sum to 7? We could throw a 1 and a 6. We could reverse that and make it a 6 and a 1. We could throw a 2 and a 5, reverse that and make it a 5 and a 2. We could throw a 3 and a 4 and reverse that and throw a 4 and a 3. So there are 6. A sum of 9. We could throw a 3 and a 6, reverse that for a 6 and a 3. Throw a 4 and a 5, reverse that for a 5 and a 4, and that's it. So there's a sum of 4. There's a total of 4 different outcomes when I throw 2 dice that would sum to 9. So the probability that I would throw a sum of 7 would be 6 out of 36. There are 1, 2, 3, 4, 5, 6 favorable outcomes divided by 36 equally likely outcomes. And then I'll add to that the probability that I would throw a 9, and there are 1, 2, 3, 4 favorable outcomes divided by 36 equally likely outcomes. So we would have a probability of 10 out of 36, which could be reduced to 5 out of 18.